And so last week, I promised you that we are going to follow a schedule. A schedule which allows us to learn the, the language in 12 weeks. 12 weeks is like, let's say, 3 months, approximately 3 months. And we should be able to do that. And so this week is week two. In week two, we are going to, and I said that if you have any question, feedback, you can always send me a mail. Um, at nanayao@gmail.com. Um, so in week two, we are going to look at the basic data types and operations, the basic data types and operations. And this involves us looking at data types, variables, operators, vector sequences, and maybe indexing. So that's our goal for week two. Remember, if we follow this plan, in 12 weeks, we should be able to uh, do R programming very well. And so stick with me so that we can go through. Let's start with something very crucial in programming um, for this week. Um, variables, variables. And week two, we said variables, data types, and operation. This is for lesson one. So let's look at what it offers. So if you learn any programming language, there is one concept that runs through every language I have seen so far, and that's the concept of variables. Um, we'll look at what variables are, we'll look at how to name the variables, we'll look at how to assign things to the variables, and look at the scope of the variables. All of these things will make sense as we go on. And we'll take our time and go through it fundamentally. So if you don't have any experience in programming at all, you will still succeed at this, at understanding this. If you have some experience in programming, then stick with us and then bear with us as we go through the fundamentals. Okay. So a variable is more like, in a layman terms, a variable is like a container which you can store a value in. So let's say you have a box that the box can hold an item. Okay. That box is the variable. Okay. That box is the variable. And it can, in programming, what variables do is they store data or values. They store data or values. And why do we need to hold data temporarily as our program runs? Because sometimes we get data which we will need to work on along the way or process along the way. So we need to hold it somewhere so that our program can work on it as it's held in there. And in the process of doing that, that's why we need variables. So think of them as containers that hold values. And over here, we said that a variable is a memory allocated for holding data. Data are also values intended for future reference. This is because in the run of the program, sometimes a user will give you details and you need the details to do something. So for example, the user gives you their first name or their last name, and you need to talk back to them and need to maybe address them with their first name. Okay. And in doing that, you need to hold it in a variable so that when the program needs it, it can retain it. And you have to give this variable a name. Okay. And so I will demonstrate how it's done. The last time I told you guys that if you installed your R, if you have installed it, you should find the R Studio on your desktop, this icon, okay? And you can click on it and it will launch your R for you. So we are going to launch the R and then try demonstrating how variables can be used, okay? And it's not any complicated thing. Variables are the most basic concepts. You find them everywhere. So if you learn variables in R. When you go to Python, you find them there. When you go to other places, you still find them in variables like JavaScript. You find them almost in every language. So let me say there is a value I have that I want to give to my programming language so that it can hold the value for me. I need to create a variable and then assign a value to the variable. And so I have, let's say, my var. My var is my variable that I've created. I can assign a value to that variable by using equal to, let's say, Nana, with my first name. I can assign that value to it by using equal to. And now look here, values, Nana. Okay, so it means I've created a variable called Nana. This is shown in my global environment that I have a variable. So when I write thousands of code, let's say 1,000 lines of code, later on when I can still access my variable and say print. Let's say I go and do something else. 1, 2 plus 3, 2 plus 3, or 2 plus 2. And I say that's 4. Okay, I go and do another operation. 6 plus 3, and that's 9. And I come back and I need that value because I have stored it in a box or in a container. I can go fetch it. And that's the purpose of variables. So I can later on come and then say, cat, do this for me. Hello, my var. Yeah. I'm just demonstrating how we can find variables useful. So I say hello, my var. So it says hello, Nana. Now it gives me the value which I saved in the variable my var. So this is how variables can be useful. First, you have to give it a name, any name of your choice, and we'll come to how to name the variables because it has rules that govern the naming of the variables. So let's get back to our slides, and then this is a demonstration of how variables are used in programming. So we can have 1,000 variables, but anytime you create a variable, remember that a memory is allocated on our PC. So the more variables we create, the more memory our program is going to consume. Okay, or random access memory, RAM, like the way we say it, is going to consume for holding data values. Okay, the data is what I supply to it, or the value is what I supplied as Nana to it. Okay, and we can reference it in the future as long as the program runs. Okay, and the name given to the variable is called a variable name. So let's get that. And more on variables in our language, similar to Python, we say it's a dynamically typed language because you don't need to declare the variable with the data type. In some languages like C or C++, you need to do that. You need to tell the type of the data before you can use a variable. So it means that when you do that, you've locked it in. It can't accept any other data type apart from the data you specify. So if you say it's an integer, it's going to be an integer throughout. However, in Python and in R, that's not the case. It can take any value at all. So creating a variable in R, that's what we just demonstrated. The first thing is you name your variable. Okay, we name the variable. So over here, we name the variable my var. And we introduce an assignment operator. So we can use this for assignments, this less than dash, or double less than dash, or equal to. We can use that in assigning a value. So that's what we have introduced here, less than dash. Okay. Then we assign the value we want this box or this container, this variable to hold. And we assign it here. So when we say this, for example, outcome is equal to 20. When we go to our RStudio, we find out that, okay, so we can have outcome as the name of the variable. And then this time we are going to use this to 20. We set, this is read actually as outcome gets 20. Okay, outcome gets 20. So we set it to the value of 20, and from there we pick it up. So as we do that, we remember we come to our environment and we see that it has been listed here. Okay. So that has been listed. This is a very good thing for us. Okay. So that is one thing with variables. Sometimes in running our program, we need to refer to data, and that's how come we hold them in containers we call variable. And you will create the variables yourself. The program will never have any variables created for you. You are going to create the variables yourself. And let's talk about naming a variable. Okay, so even though you can pick any name of your choice, there are rules governing it because the syntax of the language permits certain things and doesn't permit certain things. Okay, and these are not very strange rules. A variable name, first thing is the naming convention. A variable name must start with a letter in A, B, C, D, Z, and can be a combination of letters, digits, a combination of letters and digits. Let's say Nana 20. We can have something like Nana 20 being the name of a variable. And you can have underscores in there too, and you can have a period in there. He says that if it starts with a period, it cannot be followed by a digit. Okay, if it starts with a period, it cannot be followed by a digit. So that means that you can't have, let's say, outcome saying that outcome is, you want to call your variable number 2 outcome like this and name it, give it a value of 1. It says an expected symbol. Okay, it means it's wrong. Okay, but you can have dot outcome. I'm pretty sure, and that works. So if it starts with a period, it cannot be followed by a digit. Okay. So now we see dot outcome here. Okay. So that's how it kind of works. So let's go. And it says that a variable name cannot start with a number or an underscore. Why? Because sometimes you have, why? Because sometimes we have we have issues. The programming language itself reserves certain symbols for its use. So it's better to understand that you cannot start with a number or an underscore. And then variable names are case sensitive. Age and this age and this age are different variables. Case sensitive means that the capital A and the little a, the little a shouldn't be like confused. So let's say I decided to clear my screen, and then go to my RStudio. I just wanted to demonstrate how we use variables and how we name variables. And these are simple rules. If you give them a basic name, you wouldn't have challenges with some of these things. Sometimes you don't have to give a variable a so much complicated name, because if you give them a complicated, sometimes it becomes easy. It becomes less easy to remember them. Okay. So let's say you have a variable called we are going to demonstrate how age is, you set age to 20. Then you come here and you say print age. Brings 20 for you. Okay. You set this age to 40, this capital H to 40. And you come here and say brings age for you, or brings this small age. It will still bring the 20 because this age is what it doesn't recognize this age same as this age. Okay, but when you say brings capital H, then you are going to get your 40. Okay. So variable, it's important that when you are naming variables, it's important that if I say this variable is called Nana Yao and it's set to 23, then I should bear in mind that it's not the same as this Nana Yao, which is set to 24. Okay, so you can see this Nana Yao and that Nana Yao appears as different variables over here. They are not set as the same values. Okay, so it's important to bear that in mind. Let's continue with variables. So these are kind of the naming conventions, and reserved word cannot be used as variable. In every language, it has reserved words because the words are sometimes used for the program's purpose. So you have true and false reserved, you have null reserved, you have if, and we'll go into more of reserved words. If you want to check out more of reserved words, you can simply type reserved. Okay. So once you type this, it brings you reserved words, all the words that have been reserved. So if, else, repeat, while, for, next, break, through, for. It brings you all of them that has been reserved. So you can't use them as your variable name. So I can't say, okay, I want my variable name to be called repeat. So repeat, set repeat to 20. No, so you see, expected error. I can't say I want my variable to be called if. So if 30, it brings me an error. Okay. So these are reserved by R. Okay. And anytime you forget, you can just bring a question mark and type reserved. And it brings you all the reserved words which you can't use here in your help section. Okay. So you can't name a variable as a reserved word. So here we look at the good examples, some good examples of variables and some bad examples. My var is a good example because it follows the rules. It doesn't break any rules. True, my var is a bad example because it begins with a digit. Okay. My underscore var is because say it can combine with symbols, but there are symbols that you can't use. Like for example, this particular symbol at. Okay, an underscore you can use. A dollar sign you can't use. At you can't use. Several signs you can't use them. A character sign you can't use them. So it's important to look at these examples. My var, even though this is capitalized, it's accepted. Capital all caps is accepted. My var too is accepted. But when the two begins with variable name, that becomes a bad example. It's not accepted. Dot my var may be accepted. Okay, so let's try that and see. So dot my var, set that to 2. So anytime I set dot my var, maybe it has to do with the Python version I'm using. Okay, let me say print dot my var. Let's see. It has the value in there too. But when I bring a dot behind it, these values are not, they don't show up here. So that's one way we can name variables. It's important to practice because for me, I believe in keeping it simple because that helps you. My personal choice has to do with This is called camel casing because when you start with a capital minus, when you start with lower caps, then you raise the cap when it's a different word. But my personal choice is the use of underscore to separate words. So, for example, if I have things like first name, last name, I can say first name is Nana, or Nana, and last name. So I like to use, because it's simpler, is Kwamwa. And then I have these variables created for me. My first name is here, my variables have been created in the program I'm running for me. So I can say cat, first name, cat say my full name is come here and then see my first name and then see my last name. Once I hit enter, see my full name is fetches my first name variable and add my last name variable, which is a way of combining. So I like that convention because it helps me separate. But you can't use this dash, this particular dash in between variable names. And you can't separate the variable names. For example, call it, let's say, first name. You want to say first name should be Nanayao. Then that is going to flag an error. Okay. And you can begin with this as well, because this is reserved for reserved stuff. Okay. So you have my var. This is also not accepted, and true is not also accepted because true is a reserved word, like we were saying. So if you want to call your variable, let's say, false, or even t is equal to 6. We should have issues because t, oh, we accepted t, okay. So let's say true. 2 is equal to 6. Then t, true is a reserved word. So it can't be a variable. Okay. So whenever you have a name coming up in your mind, sometimes if you are confused, you can always come and then check in the reserved word library. Let's look at keywords. I said keywords are also the same as reserved words. Okay. Keywords are specific reserved words in R, each of which has a specific feature associated with it because of the features associated with it. So let's say you can call your variable for let's say Nana for 6. It's because it's 4 is reserved for conditional programming. So I'll give you an example. For example, we can say for x in 1 to 5, 1 to 5, do this. For x in 1 to 5, do this, print each value. So you can have here, so it lists all the values, the ranges, the range here. So because this is for conditions, this word for is reserved for conditions, you cannot use it as a name of a variable. All right, so these are some examples. We have if, else, while, repeat, for, in, next. In is what I look for. So we find this example has for here and has in here. So we have for here and we have in here. And all of these things are reserved because they are used in R programming. Okay. Okay. So let's look at assigning, how to assign values to a variable. So we've seen some example. First, you write the name of your value, here my var, and then you enter the value you want to assign to it, you want to give to it. So you can have pets here. So pets, your pets are a cat, a dog, a parrot. There's a vector of, then that assigns the values to pets. Okay, there's a vector of pets, and this nums is also a name of a variable, and you can say a range of 1 to 10. In R, for us to write a range, we usually use the column. So if you see that convention of two numbers, it means give me the list of integers that runs from the first number to the last number. Okay, that is 1 to 10 over here. And so that's one way variables receive values, okay, or values are assigned to a variable. Remember, when you name a variable, you give it a name, you have to assign something to it. So there's a box you have created, it's taking memory. So you assign a value to that box, that particular box. And then the next example is like receiving data for functions using prompts. So let's look at this example and say, okay, this time we want the user to give us the information so that it becomes more dynamic. Okay? So we say, we want to write a simple program that allows the user to do that. So we say, we want to create a variable that holds the first name, like we did over here. The first one, we manually entered Nanayao. This time, we want the user to give us that name. So we create a variable called first name. And then we say first name should hold this prompt. It should hold, there is a function we call readline, which allows you to take data from users. So readline should have this prompt asking for the first name of the user. So the prompt can say, what's your first name? And whatever it enters will be stored in our first name. So let's look at the first name variable we have here. We have it set to Nanaya. Okay. So I run it and it asks me, what's your first name? And I say, my first name is Jessica. Now we see what happens to the value we have here. The value we have here has now been set to Jessica. Okay, that means that in variables, when you have a variable and it's set to a particular value, and along the way, you assign another value to it, it overrides the first one. Okay, it overrides the first one. So let's say if I run that program again, what's your first name? And it asks me for my first name, and I said, my first name is Philip or Phillips. Then Phillips overrides the first name over here. Okay. So that is one thing to take note of, so that you don't create a variable and forget that you've created a variable, then you go and use that same name again, and you assign another value to it. You override the first one. So that's one way we can receive data from users. So this time over here, we let the user enter their name, any name they are interested to put in there. Then we hold it in the first name variable. And later on we can say, hello first name or hello Philip. So hello first name. Okay. Says hello Phillips. Whatever value the user gave to us is set this time to the variable the first name. Okay. And So these are two ways which we can assign values to variables. Okay. So when we create the name of the variable here, in the first thing, this time it says it should read and then assign the value it gets from reading what the user gives to it to the first name variable. So you can assign your values manually, and you can also receive data using a function. So let's talk about one thing which is also very important. That is the scope of a variable. Okay. Remember that in programming, now all the variables I've created here can be accessed. I can come and say age. Age is set to what? 20, right? I can type age and then it will give me the value 20. Okay. I can say first name. And then it gives me the value for first name. I can say Nana underscore Yao. And it gives me the value of 24 because over here I have it defined as that. It's important to understand that these values we are creating have limitations when it comes to the section in which they can. So let's say over here, age is set to 20. And I say, okay, I'm writing a function. So new function, new f. Okay. And I say this function should be equal to function. Forget about all of these things. And then I want to, inside this function, I want to set age to this age, this particular age. Inside the function, I want to set it to, the value we have here is 20, right? This time I want to set this age to 30. I have set a function, I've created a new function. So when you come down here, you can see new function is here, right? Whenever I call, so let's say if I ask now, okay, over here I set the age to 30. But when I call age here, I still have 20, even though I have set the age to 30. Okay. Why that is happening is because this age has been set within these brackets, the first curly bracket and the last curly bracket. So it's more constrained in the operations of this scope, of brackets. So any other code, if I come to the first one and I say it should print the value of age, it will give me age is equal to 30. That is if there is a code to do that. So let's say the new function I wrote, let's say I go back inside my function and say, hey, after you are done, print age. Whenever I call you, print age, the value of age. Okay, so the function has been redefined. Now that when I call new function, it should, this is how we call a function. I name the function new f. When I call it, it should give me the value of age. Now the value of age inside this function is 30. So it gives me 30. But if I come outside the function and I say age, that gives me 20. So this age and that age, even though they have the same name, because their scope is different, they don't hold the same values. Okay. So this age is only accessible by when I call the function or variables inside this particular curly braces. Okay. So even though it's a variable and it has a value, it is not accessible everywhere. We call this type of naming as local variables. It's local because it's been constrained within this scope or these curly braces. It's constrained in there. That means that only variables or functionalities that are inside this scope can access. It's local. But this age here is global, it's a global variable because it can be accessed by all other programmers. So when I say, give me the value of age, now it should give me 20. But if I run the function, and say new f, do your thing. If I call that function, the value of age inside there is 30. So it's worth understanding that there are, even though we have name variables, you also have to understand the scope within which the variables operate. And that is what we'll talk about. So the scope of variables, I said that the location where we can find a variable and also access it if it's needed is called the scope of a variable. Okay. The location. So if it's located inside a function, then it means it's accessible only inside that function. You can't access it from outside. Okay. So there are global variables like the age, the general age we found, like this one. This one is a global variable. The age here is a global variable. And the age here is a local variable. Okay. So they are local variables. I said global variables are those variables that exist throughout the execution of the program. So you can access them. They exist. It can be changed or accessed from any part of the program. So you can, let's say you are writing your program, you've gotten down there, you say, okay, now I want to change the value of your age. Your age you requested was 20, but you said no, that age was wrong. So now you want to make your age 15. When I set this to 15, what happens is over here, you see the age we set to 15. But when I still run my function, the local variable is not affected. It's not affected because it hides inside locally. So it's still 30. Okay. So local variables are those variables that exist only within a certain part or block of the program. So they are variables that have been enclosed and are released when the execution of that block ends. Now, when the execution of that block ends, it's automatically deleted. That's why we don't have age showing up here. We don't have this age 30 showing up. Once you run it and it shows it, then it deletes it. Once the function ends, it deletes it automatically. So it's always important to understand this, that variables have a scope. The scope is like the levels in which you can work in. And you can, even though they may have the same name, if it's found in the, it's enclosed inside a block, then it wouldn't be accessible outside the block. Unless there are cases where you can return that value, and we will get to that. Okay. So that's example of a global variable and a local variable. I think that will be the end of variables for us. If you have any questions on variables, my email address, it's here. And you can always send your questions. So we said we'll work on variables and we'll work on data types and work on operators. So I'll see you in the next lesson. Thank you and bye for now.